So this video, we just are going to use those properties we had on the previous video to solve some equations. So you might want to have the PDF out where you can see what those things are so you can kind of follow what I'm doing. But you should get to where you can follow what I'm doing without looking at anything. But you might want to look at them first a few times and then maybe go through it and try to do these problems yourself without looking at anything else, just using the properties. So the first problem here just says expand the expression as much as possible. This is just worded the way your text words it. There's other ways of saying it, but this is how they do it. I think it's pretty clear. So expand is like, so if you had, it's like going left to right on the identities in the previous page. So if you had, say you had log base 10 of 2x, expand would be you'd have log base 10 of 2 plus log base 10 of x. So that's expanded. You have more logs. Okay, so that's what you want to do. Left to right on all those, on the three identities, number 3, 4, and 5. Okay. So the first thing I do, and so I'm given this thing, this kind of complicated looking thing, log base 5 of the cube root of x squared y cubed over z. And so the argument of the log is that whole cube root stuff, the whole thing there. And it's a base 5. Okay. But that doesn't matter. It just means that I'm going to have base 5 all the way along. Unless I have an exponential function base 5, it's not going to really come into play. It's just carried along. Okay, so the first thing I do is I write the cube root as a 1/3 power. This is one of the reasons we had to learn that a cube root is a 1/3 power and a square root's a 1/2 power, etc. Because you need it here. Okay, so that gives me a power, so we can use the power rule, which just says that 1/3 right there, that 1/3 just drops down in front here. Because this 1/3 is inside, see, the cube root is inside the logarithm. And if it helps you, you can put parentheses here, right? That's not these parentheses. This 1/3 is inside the logarithm. So it drops outside, out front, becomes a product. That's that rule number 5. Okay? Now we can apply the product and quotient rule things here. And you could do this all at once if you want. This is actually, well, let's just do it this way. So we can do the x, the y, and the z all at once. And remember, the whole thing's times 1/3, so I'm going to need parentheses because this is turning into a sum and difference. But it all has to be multiplied by 1/3. So I'll have parentheses. And I'll just do all three of these at once. So you'll have log base 5 of x squared plus log base 5 of y cubed minus y log base 5 of z. It's that easy. It's not hard. You just have to get to where you understand it. Once you understand it, it's not like, it's one step there. It's one step. Now notice I've got several terms, each of which has this, well, 2 of which have this power. Right? So to expand, what they mean when they say expand is you would have to put this 3 down here and this 2 down here. Right? And then you'd be done. You could distribute the 1/3. I think I did, just because when you put the 3 down here, the 1/3 and the 3 will cancel. But the other ones, they don't. So it doesn't really matter. Right? So it looks like that. See what I did? The power inside the log became a product outside the log. And I just distributed the 1/3 just because I like that the middle one reduced, even though the other two didn't. But I don't really know which one's better. I think maybe they want the second one. Okay, that's expanded as much as possible. Now, going the other way, they would say compress the expression as much as possible. That's almost a tongue twister. Compress the expression. Nah, it's not that bad. So now I've got several logarithms, and you want to make one logarithm out of it. That's what compressing it means, okay? Now, this first one could have been expanded more, but they just gave it to you partially compressed already, which is fine. But you're going to compress them. And actually, the reason why I wrote that out that way is because you want to know what does it mean, compress or expand. And if you could do this wrong by expanding this and think you're compressing, but no, I don't think you'll do that. Compress just means make one logarithm out of these. Some textbooks will just say write the following as a single logarithm with no coefficient. Okay, so you're going, this is practicing going right to left in properties 3, 4, and 5 that I had on the previous page. Okay, so I'm going to put what? So the first thing I did is I get the coefficients out of the way. So I put the coefficients up on top. Because the rules that we have, 3 and 4, the coefficients, look at them, the coefficients are 1 or could be -1. But there's no coefficient of 3. There's no rule there for coefficient of 2. The only rule for a coefficient of 3, a coefficient of 2, is rule number 5. I'm trying to remember the previous page. It's rule number 5. The rest of them, they got to be coefficient 1 or 2. So you can't put these two together using the difference rule. Well, those two you could. What am I looking for? These two. You can't just put these two together using the difference rule, because the difference rule has a 1 there and a 1 there, right? And this doesn't. So you have to get a 1 there and a 1 there, or a -1 if you want to think of it that way. Okay, so that's why I did this first. Because see, now I got coefficient 1, coefficient -1. Now you can put these two together using the quotient rule. You get 5 to the third over 5. Yeah, 5 to the third over z squared inside, right? And this here, you'll get times that as well. So I can do them all three at once. So you just get this. The ones that are added are multiplied, and the one that's subtracted is divided. See that? And I took the 5 cubed and multiplied it out because, yeah, simplify. Okay? And if the inside reduced at all, I would reduce it too. Like if there was an x over x or something. Where am I pointing? I'm pointing up here in space. See over here? Sorry. It's kind of hard to get this pointer right. If you saw how I was doing it, you would understand. So, okay, so this is, if there was an x over x squared, I'd reduce that, right? Always reduce your answers. Okay, so that's it for that chapter. So just practice those until you got them down cold. That's the important thing to do. And it's the kind of thing that you really can get down really well without too much work. Just try to understand it first. Go through the ones that I did, then try to go through the ones I did without looking at them. And then try some other ones out of the practice. Okay, but get to where you can do the ones I did first. Okay.